Got it.
Hi, everyone. Christina and Rusty here with a special guest that we will introduce you to in just a moment. This month, we are covering setting up a successful robotics program. It is August. People are going back to school. Teachers want to know, how can I get going with robotics? So we're going to tell you all about that today. So you'll want to make sure you connect with us somewhere. There's our email address if you want to reach out just to the group. Social media, we are at UBTECH EDU on all platforms. Please find us, follow us, share. Tell us what you're doing. We always want to know. And then our website is ubtecheducation.com. You can find out everything you want to know about UBTECH and what we offer there. Please note this webinar will be recorded. It is being recorded right this moment, and a link will be sent out along with a survey tomorrow, asking you, to report back on what you thought and what you'd like to know more about next time, and maybe what we didn't cover for you yet. So please be on the lookout for that. All right. Our agenda today. Rusty, you want to cover UBTECH this time?
Absolutely.
Yeah. Okay, so Rusty's going to tell you who we are and what we do. We're also going to talk to you about exploring the UKIT, so what UBTECH has to offer in terms of robotics and how we suggest getting started just with what we offer. And then you're going to hear from E.C. Setzer, who is one of our TAP teachers, and she's going to tell you all about what she does in the classroom with robots and with her students. And then we're going to do a little bit of Q&A. So if you have any questions, please feel free to put those in the chat or the Q&A section at any time. We will try to answer those as we go if we find some good questions that go along with what EC is presenting. But outside of that, then we will go ahead and save them for Q&A at the end. So little introduction. If you've not been with us before, we've been doing these for quite a while now, but my name is Christina Davis, educational specialist here at UBTECH. There is my email, my Twitter, and LinkedIn handles. If you want to connect with me, that is fantastic. And then I will let Rusty introduce himself.
Yeah. Hello, everyone. So my name is Rusty Nye. I am the education product manager for UBTECH. And there's my email on the screen and also my LinkedIn. I don't really use Twitter so much. So while we get going, I see there's a bunch of new names, a bunch of people jumping in. So feel free, if you'd like to introduce yourself in the chat. Feel free to drop in where you're from and say hi to everyone along the way.
Perfect. And we already have our first question. Yes, this webinar is recorded. All of them are recorded. They're all sent out the day after our webinar and will be posted onto our website and YouTube page. So you can always go find these afterwards. All right, Rusty, it's all you.
Great. So before we dive into the bulk of the presentation, we always really like to, introduce who we are as a company. UBTECH Education is a division of a larger global entity, UBTECH Robotics. And the reason why this is important is a lot of the same technology that we put into our educational products come from our parent company, UBTECH Robotics. And I do like to touch on a few of the robots that we're currently working on, particularly if you direct your attention to the center robot in the screen. That is Addibot S, which is one of our disinfection robots. So this is a robot that's utilized to disinfect environments utilizing UVC technology. So we have a bunch of cool stuff with our parent company, and I'd strongly encourage you guys to check out kind of what we're doing. But Christina, if you wouldn't mind advancing the screen. To cite specifically who we are as a branch of UBTECH Robotics, UBTECH Education is a division where we emphasize and create different solutions for our fellow teachers around the country, I should say. So we are a North American specific division of UBTECH Robotics, where we really try to establish and bring fundamental science, computer science, and STEM curriculum with our robots into the classroom setting. With this bigger goal of trying to develop computational literacy, along with those 21st century skills. We are a team. A lot of us are former educators, myself as well as Christina. So we are trying to create products and services particularly focused and designed for you guys in the classroom. Excellent.
We didn't talk about who's tackling. Rusty, we want to do, who wants to do this one?
I can dive in for sure. Sorry. It was a
Okay,
little
just
lagging on my side. I don't know if that was anyone else's, but hopefully my Wi-Fi is good. But within our products, what we're currently offering is a vertically aligned solution to bring engineering kits into the classroom. So we have 3 different classroom kits. So these are engineering kits, meaning they are a bunch of disassembled pieces where students utilize our software to follow directions, to assemble robots, and then program those robots to, achieve different sorts of objectives or solve different problems with their robots. These are grade banded in terms of our curriculum. However, we see a lot of educators kind of overlapping with those grade bands to bring in these kits at various levels depending on the experience and perspectives of their students.
And I will, I can never remember if I'm muted or not. I need to quit doing that. I will jump in with grade levels real quick, just because in the questionnaire before the webinar, we had some people ask. So our beginner kit is, all of these are written for NGSS standards. So we have STEM units for those. The STEM units for the beginner kit are grades 3 through 5. Those are the standards they hit. The intermediate kit, oh my goodness, is 3 through 8th grade. And then the UKIT Advanced is 6 through 8, just in terms of those STEM standards. Those NGSS, and then it can go up higher because it has the Arduino microcontroller, compatible microcontroller. Then we can go up into high school, and even we've had some college students use it as well. So kind of like Rusty said, just depending on where your students are at and what you're comfortable with.
Great.
All right.
And,
so
go ahead, Chris.
Are you going? Sorry, I thought you were taking this one.
Oh, I definitely can. Sorry.
Okay.
It's been a while since we've done 2 months of recorded webinars. So excuse us while we kind of, get back to the swing of things. But
right.
In terms of
this one, so I apologize, Rusty. All these images are awful right now.
Okay, I was wondering. I was hoping that was just on my screen, but I guess it is on everyone's. So
on everyone's screen. Sorry about that.
No problem. Great. So in terms of what we offer as an education company, so we currently offer hardware as well as software kind of as a total package. With that being said, kind of our third offering and layer is our services as well as curriculum. So our kind of bringing this down to the classroom level, we offer kind of a full package, so a one-stop shop, so to speak, and bringing a total robotics solution to the classroom. With that being said, getting started with the UKITs, we do offer implementation guides, which kind of bring different types of strategies, so to speak, for being successful in the classroom. And Christina, if you want to advance slides. And Christina, you can help me out with this one for sure, because we've kind of developed these, together, these strategies. But I'll tackle the first one, and then maybe if you want to chime in for sure. Okay. But these are some overarching strategies that we've seen when using the UKIT solutions in the classroom that help inspire the educators to be successful. These could be a little bit, on the nose, if you're kind of looking at our solutions, but it's something really worth noting. So kind of the first strategy that you can utilize when taking the kids is to follow our STEM curriculum. So we have some very detailed integrated STEM curriculum that really can meet the needs of the students kind of coming together, utilizing the kids in a very prescribed way. This is great for educators that have that dedicated time built into their schedule in order to bring robotics in the classroom. This is also best for those educators that are trying to find different ways to connect to next generation science standards or trying to address cross-curricular concepts. Because of this, we provide this really nice framework for educators to kind of be successful and work with the kids within their setting. However, that's not, of course, the only strategy that we've seen that really works with the UKITs, and we'll touch on a couple other ones. So, Christina, I'll throw you at you for number 2.
Yeah, and to follow up with the curriculum that Rusty just talked about, our STEM curriculum is pretty intense. It is oh gosh, I think our shortest unit is 2 to 4 weeks if you did it an hour every day. And so just know that it's a big time commitment for sure. It could totally be broken up. You could do like 1 or 2 lessons from the guide, just depending on what your goals are and what you're trying to meet, like Rusty said, in your time frame. But do know that that's a pretty heavy in. And we did that specifically because we want to try to bring robotics into outside of just after school programs, right? We want it into STEM classrooms or regular classrooms or science classrooms. And so we're trying to build those cross-curricular concepts in different ways that you can introduce the robots. And so there is a bigger time commitment if you're going to follow the curriculum. Number 2, so another option that you could do is you could use the recommended robot models provided in the app. So you could just have students build. Our software is free, our curriculum is free. So you could get in there and just have them start working through that. You don't have to have dedicated lessons. You just need to dedicate some build time for that. And then you could do activities outside of that. Maybe they're trying out the sample code and seeing how it moves. Maybe you're having races with the dinosaur, which would probably take forever, but it would be fun. Maybe you're doing obstacle courses with the trolley. I don't know, but you can totally do just standalone activities. Once they've built it, they can test, they can play with it, and just kind of have fun with it, as opposed to really trying to meet certain standards and those types of things. So that would be my suggestion for number 2. Tying back one more, and then I'm going to switch it back over to Rusty. So tying in one more thing with the curriculum, we do have other curriculum options. So if you want to do more of an easier in, we've got units called Beyond the Classroom curriculum that was our Campus-Inspired curriculum, switching over now to the classroom. It's 10 hours, so that's a lot easier of an in than just going into those STEM units. And then we also have UKIT Spark Starters, which are little activity cards, very open-ended prompts, and those could be used for a class or a couple of classes as opposed to doing full lessons. So number 3, Rusty, on to you.
Yeah, great. So, and another strategy that we see that's worked really well is to take it even a step further or a step back, depending on the way you're looking at it. But really focusing on the robot building as a tool upon itself. And what we mean by that is having students kind of invent their own robot. We actually do have a dedicated curriculum unit called Robot Inventor from our summer camp or Beyond the Classroom curriculum set, where we kind of guide through this focus of the students. So this is also a kind of great what I see it really working is utilizing it within that STEM setting. So if you're a dedicated STEM teacher and you're really trying to have students engage in that engineering design process, kind of going this route or utilizing this approach would really meet the needs of those skills you're trying to develop within students. So to kind of summarize kind of the thought process here is, yes, we have dedicated curriculum, which is what the educator can follow to a T and move through to meet the objectives we've set within the curriculum. Or you could utilize our software as that guiding light, and then kind of setting your own objectives of coding and usage of the robots. Or you could kind of go this other approach while focusing on the engineering aspect, where the students are really trying to build a robot to meet specific needs. So there's a lot of different strategies. These are just kind of 3 we picked out to kind of throw at you guys to have those cogs start turning.
Absolutely. And we're going to go on to a couple more things from us before we switch it over to EC. But just before I forget, these tips and like what we just showed on the last slide, they all come from our implementation guides, which you can access on our website. In the top right corner, if you go to ubtecheducation.com, there's a login register link or button. So you can just click on that, register for an account if you don't already have one, and then you get access to a sample of all of our curriculum. You also get access to these implementation guides. So you can download them, read through them. We've got sample, like Rusty's done a great job of outlining what a class could look like. Here are some different things you can think about. We've put in sample lessons, just a lot of different resources to try to help you guys get started. So that being said, let's go on to this slide. So designating rules, I think, are fantastic. I was a former elementary teacher, and so your students had to have a job at that point, or it would be like chaos, right? Organized chaos in the classroom. So I always designated roles. We suggest 2 to 4 students per kit. We never suggest more than 4 if you can avoid it. You're always going to have a student then that has nothing to do really, because 4 kids on this kit is a lot. And I'm sure EC is going to touch on different ways to kind of how she's done it with students, where you could have 2 doing something and 2 doing something else. At the end, we can recap that as well. So some example roles: mechanical engineer. So they're the lead for building the robot. You could also break the robot into steps, right? So one student does steps 1 through 4, one student does steps 5 through 10, however you want to break that up. Supply engineer, this could always be more than one person, because in our app or on our UCode, which is our browser-based platform, we do have an inventory list for each build. And so one student can be like looking at that, telling the other student what to grab as they're collecting. And it's always good to have 2 eyes on that, right? On all your pieces. Project manager. So this would be the person who is controlling the app or controlling the browser, or maybe just kind of leading the group. And then a quality control manager is always fun. They're the ones that get to test the sample code, make sure the robot is built correctly, that it's running correctly. Rusty, over to you for classroom management tips.
Yeah, absolutely. And yeah, a couple of tips that we kind of thought of are, creating that excitement with the UKITs. So, the UKITs are fun. Kids will be very excited when utilizing them. So think about how you can, and it's, I'm reading from the screen, but how you can anticipate that controlled chaos will definitely be helpful. Also think about the frustration students may experience. We are working with new technologies, so celebrating the effort over success is definitely helpful. And lastly, kind of encourage that creativity. There is no limitation to what the students can, come up with, with the kids, with their robots. So don't be kind of constrained by the curriculum, by the software itself, but really try to encourage students to think outside of the box. This is easier for students than adults, I find. So definitely trying to go through that mindset of the student will definitely help ensure that you're successful when you're trying to utilize them in the classroom.
For sure. And before we move on, I will ask Rusty. I know he answered in the Q&A. I'm not sure if everyone sees that or not. So we'll ask it here, and then I will also ask EC her thoughts on this. So how long do you find that it takes students to get used to the kit? EC, if you want to jump in, or Rusty, I don't know who's ready to go first.
Sure. I find it depends on the kid, but they do it a whole lot faster than the adults do. The kids learn it right away, especially your Lego building kids that already have done this before. They pick it up super fast. But the rest of the kids jump right in, and they love teaching each other. That kid that knows how to do it already likes kind of bossing the other ones around.
For sure. And we've got some great questions in the chat right now that I know Rusty's going through and answering, but before we turn it over to EC. So yes, you can use Chromebooks with all of our both of our platforms, the app and the browser-based platform. And then does it work on iPads? Yes. So anything you can download the app on, it should work. That's for the UKIT beginner that you see in the picture there, and then the intermediate, which is blue. Once we switch over to Arduino, that is browser-based. And so that does need to be on a laptop or Chromebook, some sort of device where it's optimized for browsers. We do suggest Chrome, and you do need to have a USB port to plug in your robot. So those are the 2 big differences. Just with the app, just using the app goes on devices or mobile, and then the browser base goes on a laptop or Chromebook. And fantastic, EC. Yeah, I was going to add into there that we have some very easy builds that take under 30 minutes, right? I think one of them is maybe 15 minutes at most. So yeah. If you do download the app, look in the left corner. It tells you how many steps are in that model. We suggest cutting it in half. Obviously, if your kids are more used to it, that's going to go quicker, but there are some robots that are very easy to start with. Just get them building. They'll get pretty comfortable, like EC said, pretty quickly if they've done any other robotics, and it shouldn't take long. And all 3 of our kits utilize the same building structure. And so once they know one, they know the next one. So you're really just upping the game in parts and pieces based on numbers. You get more sensors and things with the intermediate kit that you don't get with beginner. And then the advanced just really jumps because you have the Arduino. So then you're really adding complexity there, more servos, DC motors, all sorts of fun stuff. But the base building pieces with the fasteners and everything are the same going through. So anything you want to add to that, Rusty? I know you were typing and answering questions.
No, I think you hit all the bullet points. So I think that's
perfect. Let's go to professional services, which is run by Rusty.
And I'll take this because I have a personal stake within it. But we also offer professional services programs. So this is being teacher training. We are also working on a self-paced training in LMS environment, which is very exciting. But currently we do offer in-person as well as a virtual training options. So to make sure you guys are successful, which we want you to be, we're not a type of company or organization where we're just dropping off, hardware, software, curriculum and saying, figure it out. We want to be there with you guys, as much as we can to make sure you guys are comfortable and to make sure that we're providing the amount of support that you need to be successful in the classroom. So if you're interested in any of our services, please reach out, please visit our website for more about what we offer. And if you have any questions, you can always reach out to me personally.
Absolutely. And I just want to throw out there, just because of the amount of questions we've had around what we offer, we're not going to talk anymore really about that because we're going to switch it over to EC. So if you look at this screenshot here, this is our website, ubtecheducation.com. There's a tab up there that says webinar series. Go ahead and click on that. Last month's webinar was on how we differentiate ourselves from other robotics. And so that one actually gives you quite a bit of information about our different kits and what we offer. And there are a couple more. Were they this year or last year, Rusty, where we talked about, like, UCode was last year. So we do have one specifically just on UCode. We've got one on different parts of the app. Like we've done a couple. Go check out our recorded webinars.
We've done a lot.
Our previous ones, right? Yeah. We'll tell you all sorts of things, or you can just reach out to us and we'll tell you more, whatever you want to know. So real quick, we have a question. Do you have webinars on programming to help us learn both UCode and Arduino? So Carla, if you're looking at this screen right now, there is a resources and programs tab. And if you click on that, there is an option for UCode resources and activities. So many UCode resources in there. There's a block guide to explain all the blocks. There's a getting started with UCode. There's a quick start guide, like just all sorts of things. We've got activities on there that you can follow or that students can follow. We've got 4 or 5 videos, one being an introduction to UCode that walks you through it. The others are activities. They walk you through different activities. So my best suggestion would be to go to resources and programs on our website and then go to the UCode activities and resources page. Check that out, find out all the things. And then if you still have questions, please feel free to reach out to us. And before I forget, in UCode, when you open it for the very first time, there's going to be a resource center. And on that resource center is a beginner's course as well that you can take that will show you how to navigate UCode. But if you've done Scratch or PictoBlocks or any other block-based drag and drop coding, you're going to be pretty golden. It should be pretty easy for you to jump right in. Rusty, anything you want to add on that? Or EC?
Yeah, just expanding on the Arduino integration and functionality of it. We also do have a working with circuits curriculum, which does feature 15 dedicated lessons based around circuitry. So that is all dedicated specifically to programming in C++ through the Arduino IDE. So it's a bit of a outlier from our other curriculum in that we're utilizing, the IDE, which is a different programming environment. And we have a bunch, including, to also kind of aid in that transfer from UCode to Arduino. We do have some onboarding documentation as well. So we have enough stuff to kind of get you started and a bunch of sample codes within the Arduino IDE as well. And then also, we can always support that along the way.
For sure. EC, anything you want to add?
Just that if you need help, these two will write you back immediately. They're amazing. So reach out.
We try.
All right, Rusty, you want to talk a little bit about Teacher Ambassador Program?
Yeah, absolutely. So this is our second year of hosting a Teacher Ambassador Program. So we'll utilize the acronym TAP from now on, but that stands for Teacher Ambassador Program. So we are working with a bunch of amazing educators, and I really truly mean that from the bottom of my heart, that really help to share our vision of trying to utilize the UKITs to inspire students. So this is a great program. We also, of course, steering you back to our website, have more detailed information on our website if you're interested in kind of going through the TAP program with us. So we currently are closed, and we have narrowed it down, which Christina, if you want segue to the next slide. We've narrowed it down to 8 really great educators for our second cohort here. I want to actually, I mean, of course, I'm not going to move through and introduce you to all of them, but I just want you guys to highlight and look at, we kind of hit, STEM educators, computer science educators from all different grade bands, all different grade levels from all around the country. So these are all educators that went through a, application process with us, and we saw that we really see eye to eye in terms of our goals and their goals. And so we're very excited to work with them moving forward. So if this is something that you're interested in, I strongly encourage you guys to apply for, next year. With that being said, you might recognize one of the pictures there. That is EC Setzer. So she is actually one of our excellent teacher ambassadors that's joining us again for a second year, which we're very excited about. And I'm happy to also call her a friend, not just a TAP teacher as well. So from now, I'm going to throw it over to EC, and EC has a ton of really great experience that can definitely help you, set up a successful program. So without further ado, I'll turn it over to EC.
Thank you so much, Rusty. So as he said, my name is EC Setzer. I am a gifted and talented teacher in Charleston, South Carolina. I'm sure you can't tell by my accent. Right now I'm teaching 4th and 5th grade. I have taught 4-year-olds. I have taught kindergarten. I have taught high school math. I teach college classes at night. So I've taught every grade you can imagine in my 28 years of teaching. And this has just been an amazing job for me because I get to test out a lot of things. I was just looking at Rusty's list of all the TAP teachers, and I think I'm the only one that's not a STEM or an engineering teacher. So if that's not you, don't be discouraged. You can make it work too. And those of you that are STEM and engineering teachers, you should be applying for sure. But let's go ahead and start with the next slide. I'm supposed to talk to you about how to set up a robotics program in your classroom. Some of you may already have a robotics program. Some of you may be going, oh my goodness, where would I start? I think you'll get tips for either end of the spectrum here. Start with a vision. Why in the world do you want to bring these things into your classroom? You've got to have a place to start, because when your administrators ask you the why, when you write grants, you've got to have your why. There is so many great whys out there. These are an innovative program. It hits all the 4 C's: collaboration, critical thinking, communication, creativity, and kids are excited. I mean, you heard Rusty's daughter trying to get in on the webinar a little while ago, right? Everybody's excited about robotics. And I mean, these kids right here, this is the way they looked in my class every single day. Can we build today? Can we get those big kits out again? So they just love it. And I think you'll all probably agree that since the shutdown, kids aren't so good at getting along with each other. They've kind of gotten bad at that. And this helps pull them back together because it's something they all have to work toward a common goal. Step 2, after you've come up with your vision, oh my goodness, how am I going to come up with the money to buy all of these kits? Well, right now is a great time to be a teacher because everybody wants to give money to teachers. And I know that sounds crazy, but all you see in the news is teacher shortages here, teacher shortages there. I threw up a Donors Choose grant yesterday, thinking I just wanted something up there for the Bill and Melinda Gates Match Day, which was yesterday, and my grant was funded. And now I went, oh gosh, now I've got to start a math team because I didn't expect that to get funded. But find something you love and put it on Donors Choose if your school district allows that. The parent that actually funded my grant yesterday, his kid left our school last year. So you never know who you're going to impact. Yesterday, I went to our neighborhood pool, and the little girl there I taught in 2nd grade, she was telling me about all the engineering and robotics classes she's taking in high school, because when I had her in 2nd grade, those are the things we did. So there's parents out there that love you and want to help you, even people that don't know you. Ask. They don't know that you want it until you ask. Tell your admin, call your grant writer for your district. There are all kinds of contests, ambassador programs. I got some cool UB kits for being an ambassador, right? Ask your parents, put it on your Amazon wish list. That is a great way to do it. Use your resources. If you know some business partners, see if, hey man, can you donate $100 toward me getting this kit? And then put their sticker on the top of the kit, right? Ask for things and hopefully you shall receive. Step 3, now I have the robot. This was kind of me, I have to admit. I write grants for things and get cool robots, and then I get it in my classroom and go, uh-oh, now I got to figure out how to use this. but these kids are super easy to figure out. And like I said earlier, if you can't figure it out, call these two, they're amazing. But sit down and play with it and learn. I would take mine home with me, and on the weekends, I would just build a robot, right? And then if I got stuck, I could get my kids to help me too. Or I gave a tub, these two boys in this picture begged me to take home a tub over one of our breaks. And they said, we promise we'll have a robot built for you when we come back. They spent their break going from house to house until they had a robot built and showed up at school with the robot. So the kids want to help you. They are dying to do this. They will come in at recess to build with these kids and to do any kind of robots and any kind of coding. Use all your time that you can. That first time in the morning, you know, when everybody's still getting settled, great time to come in and work on the robots or work on coding. Ask for help. Don't just sit there. And I got so frustrated because we have a crazy filter in our network. Probably all of you do as well, I would imagine, with today's day and age of internet. I kept getting stuck. Every time I tried to download it and submit a help ticket, I kept getting stuck. So I emailed the help desk for UBTECH thinking, oh, I'm talking to some great big panel of people. It was Rusty. He emailed me right back and said, EC, this is what you need to do. Hotspot your phone, do this, this, this. And he was absolutely right. It was fixed in 5 minutes. I should have emailed him to begin with. So ask for help. Allow the kids to teach you. Most teachers get scared of these things because they don't know how to do them. It's okay. I always tell my students, I'm not going to hold your hand and show you step by step, because 20 years from now, Miss Setzer's not going to be standing there beside you, showing you how to use some new invention. You've got to problem solve and figure it out. Give them time to play. Kids see this big box with these wires and these bricks. They want to just start putting them together. Let them do that. Yes, high school kids too. I have a college kid who still likes to come home and mess around like that. So let them build, let them play. But allow the kids to teach you. I was telling Rusty and Christina the other day, two of the boys actually taught me about the servos being numbered. They all have numbers, and we had mixed up one of the kits, and I couldn't figure out what I was doing wrong. And the kids said, Miss Setzer, these both say servo 1. That's your problem, right? They figured it out quickly. So let them teach you. It is okay. I also wrote a lot of grants where my kids would teach the special ed kids. There's a special ed class across the hall, and those kids never get to do STEM stuff because they're always being pulled one way or the other. They go to OT, PT, speech. And so we figured out they had this block of time in the morning for about 40 minutes where they could sneak into my room and I could bring in some of my kids and they could teach them how to do robots together. This program became so cool that by the third year, the special ed kids were teaching the new gifted kids that had just joined the school, you know, just come into the gifted program. They were teaching them how to code. So it was pretty awesome. Give it a try. Try it with, you know, mixed groups. It works really well. Okay, so I got off topic here. I'm sorry. Oh, springboard off your curriculum and your previous lessons. I have so many boring lessons. Take one of them and go, how can I jazz it up with a robot, right? I'm teaching angles. Oh my goodness, am I going to use the arm thing again? How many times have the kids seen that, right? Get out your golf club robot. Let him hit it at a certain angle and see where the ball goes, right? Jazz up what you already have. Don't add, oh, there we go. There's the robot guy. Don't try to make more work for yourself. This isn't more work. This is fun. Step 4, Christina, please, is organization. So there's all kinds of different ways to do this. I kind of freaked out at first. I had these big, nice kits. I didn't want to get them all mixed up. I started numbering everything. You cannot number every piece. Give yourself a break. That's insane. I numbered the big things, like I numbered the top of the kit and I'd number the motors. I also have little Sphero robots. I number those as well, just with a Sharpie. But you have to have a way to organize them. Do you want to keep the whole kit together? Or do you want to put out a smorgasbord? One of our ambassadors suggested laying it out like it's, you know, a buffet, and you put all the red pieces, all the yellow pieces, all the blue pieces, and then you send one kid to go get it. You know, you're the retriever, go find this piece for me and bring it back. Sometimes it's, you know, that's quite a hunt to look for those pieces. But you'll notice with any kid, as this gets going, the kits are going to start getting mixed. So have a plan for that ahead of time. And tell the kids what that plan is ahead of time. If you want them to stay separate, I suggest building on the floor or a table. Pieces are gonna fall on the floor, so make sure they check that before they leave. I think 2 to 3 students are ideal. You can do 4 students. Sometimes that 4th kid just kind of wanders off and starts causing problems in elementary school. High school might be a little better. And yes, just like Christina suggested, I'll do like, okay, one person builds steps 1 through 3, then you rotate jobs. Now you're 4 through 6. Now you rotate jobs. Now you're the go-getter, you're the checker. And the quality control guy, everybody likes to be that person because they boss everybody else around. So that's kind of a fun job, but it's very, very important. I have built, I've learned from a lot of my mistakes. I built entire robots and then go, oh my goodness, I put that servo on backwards. So make sure you have that quality control. It's good to have more eyes on it than you can. So one kid doesn't just become the bossy one, rotate it around. You can number the kits. Sorry, what am I missing? Oh, smaller builds versus larger builds. Somebody asked earlier, how long does it take to build? This is actually something the ambassadors kept asking for last year because some of the builds were pretty long. And I teach 100 kids. So one class would start a build. I'd have to wait till the next Tuesday till they came back. So UBTECH listened and made us some quick builds so that you can do it in one class period. So that's kind of up to you. What is your goal? Do you want to build something big that's a little bit easier to code and a little more accurate? That might take a couple of weeks of my, hour class time, but you might be able to do it in a longer stretch or send them in during recess. They love to do it. Also download all the apps and confirm they work at your school. Don't forget, schools have filters. Everything works great at my house. I get home, maybe not so much. I mean, I get to school, not so much. So make sure you're checking that, check yourself and check it the day you do it. Our tech people in my school district are notorious for blocking something the morning I'm going to do it when I just checked it the day before. So check yourself. They don't block this app. Once you've told them what it is and what you're doing, it stays. It's not a problem with that app. I always have that problem with my chess app, but this app they're doing pretty good with. And charge the servos ahead of time, because once the kids build it, they want those things to start moving. They want to see the action. So make sure you've got those plugged in for them, or just have them plug them in at the beginning, start their build, and then add them in as they can. Okay,
Sure.
step 4.
Can I add in a couple of?
Oh, please. I'm sorry. I forgot to pause it.
No, you're okay. You're okay.
I get so excited.
Some things that I didn't think about that came to mind while you were talking. So when I taught, I made sure that you become really good friends with the custodians, right? And I always made sure they kind of just knew a general idea of what my stuff looked like. And I said, here's a cup. If you find anything on the floor, please do not vacuum it. Just put it in the cup. We will figure it out later. So, and I've even got it. I don't even have a cup right now, but I just keep collecting all these little pieces I keep finding in my house. So I just put them in one space. And then when you have a student that's like, hey, we're missing this red fastener, oh, come to the cup. And then they can look in the cup and go from there. We do suggest inventorying your kits. You can do this at various times, but each kit does come with, and I should have one right here, these little quick start guides. So in here is a full inventory. Oh, it doesn't like my filter. Oh, there we go. Doesn't like my background. So we do have an inventory. So it does tell you how many pieces you should have in there. You are welcome to use that. But do make sure you go through your kits at least once a year. Try to find all the little pieces and get them in the right kits, because they will get mixed up. It is inevitable unless you are working with just like one kit the entire time. They will get mixed up. And then, like EC said, make sure your MCBs and all that stuff are charged ahead of time. Any pieces that need to be charged, your devices, make sure your devices are charged, because all your build instructions and your coding platforms are in the app or on the browser. So you want to make sure your devices are charged as well. And I had one more thing and I lost it. Rusty, anything to add to this one?
No, I think those are all great tips. I think where I also see success is having this as a step, meaning organization, taking time to think about how you're going to, actually physically organize stuff. Because if you don't, you're dealing with, 1,000 pieces with the advanced kit, 500 with intermediate, and almost 400, with beginner. That's a lot of pieces. That's a lot of stuff that can go missing. That can take a lot of time. Students are kind of moving through, sifting through different, pieces to find the right one. So thinking through, how you're actually going to organize the actual stuff, that hardware, and how it's actually going to roll out, where it's going to go in the classroom when it's not in use, where it's going to go when the students are actually building, how the desks are going to be organized. That's just going to eliminate a lot of the headaches that you may have. Part of what we mentioned, through our kind of tips where you are going to have to troubleshoot, some. There is going to be frustration. That's just the nature of working with new technology and with a bunch of students all, trying to figure stuff out, as they go. Something you can, figure out ahead of time and make sure it doesn't impact is, the organization of what you're going to do with, your program. So yeah, just taking time to kind of set through, make a checklist for yourself, how are the desks going to be set up? What am I going to do with all these pieces, these kits? How are they going to be organized? Where are my devices going to go? I mean, a number of things that might be different, per your classroom, but taking time to organize definitely will make you more successful when it comes, to game time.
For sure. And another thing you might consider, and Rusty can attest this, I am a color coded, like I like organization. I like it to be nice and clean. You got to kind of let that go because the kids are going to be using the kits. So if you can give them ownership, depending on your students and the age of your students, if you can give them ownership in unpacking the kits or organizing the kits or inventorying the kits, that makes them feel like it's theirs. And then they're apt to take a little bit better care of it, as opposed to, me going through every kit every night and reorganizing it. The kids are gonna be like, what are you doing? Like, stop.
So you don't want to do that.
Right. No, it's so time consuming. Don't get caught up on that stuff. I know some people do. And then I finally remembered the other thing I was going to mention is EC brought up a good point. If you're building one of our larger builds, so let's just say our transforming robot in the advanced kit that uses like 14 servos and all the pieces and is a massive build, and you've got 5 classes that utilize this kit, you're going to have to be creative in how you use that, because they're not going to be able to build it in one class period. So then you have to decide, does the next class get to add on to the build? Does the next class get to test with the built robot? Does the next class have to do a different activity because we just want this one class to utilize the kit? So do keep that in mind. If you have multiple classes coming in, how are you going to work through that? Because we don't want you there the first day. The kids build the golf club. The kids are working through it. It's fabulous. Your next class comes in and they're like, oh, do we have to take it apart? Do we have to start over? Can we use this one? Can we change things? It's a lot to consider before you get started. But like Rusty said, the more you think about that ahead of time, and EC said this too, the more time you spend on organization ahead of time, the easier it will be for you later on.
Yeah, absolutely.
So the people out there that are as old, have been teaching as long as me, I started to say as old as me, have been teaching as long as me, I've read The First Days of School by Harry Wong. I always say, you got to Harry Wong them. You got procedures. You just got to figure out how you're going to do it and tell them, these kids do stack nicely. And I wrote the kids' names on the kits on a sticky note to give them a little more ownership of, if a piece is missing out of this kit, I need to know who to go back and ask, because these do find their way into pockets sometimes an accident, sometimes not. So make sure, before they leave, check your pockets, check under the table, and definitely make friends with the custodians. The custodians come into my room and they say, what are these things? Can you show us how they work? And they get super excited. So involve them if you can. Harry Wong, there we go. Somebody there.
I know, right?
Harry
I got a
Wong.
question for you, EC. So if you have a semester or year-long class, or however long your class is, because you meet with them once an hour, do you have them in the same partners, same groups, or do you have them switch up for each project?
I switch up for each project. I try to keep them, because I don't like keeping kids in the same group the whole year. I like to keep them with the same kit if I can. So after, when one build is over, I might switch them to a different kit. Sometimes I will keep them together all year if the class is smaller, but it depends on the kids. If the kids are being all fine in their little groups together, it's great if you can leave them with one kit, but sometimes it's better to rotate them away from their BFFs.
For sure. That was really good. Okay, let's go on to step 5. Here we are.
Step 5. Oh, okay. And this is my classroom. Those are my feet. I apologize. Where are you going to find the time? Take your current curriculum and level it up. Find something cooler to do with it. We built Rube Goldberg machines in my room for the last several years, but this year we added our UBTECH robots and it made it way cooler. And this got way more views on Twitter than my other Rube Goldberg. I don't know if you can play that, Christina, can you?
I am actually going to put the link in the chat if that's all right. Oh,
that's a great idea. So you'll notice that, it's something we've been doing for years. Just add a robot. you know, kind of like just add water, just add robot. And then the next slide is another something I've been doing for a couple of years. This is Star Wars Day, May the 4th be with you, right? So on May the 4th, we always have some kind of challenge. And this year we built the ATV robot. I know it's kind of hard to see. When you start the video, it's a little easier to see. And I bought little plastic baby Yodas on Amazon. I took a ping pong ball and covered it in aluminum foil. And baby Yoda had lost his silver ball, right? Grogu needed to get that ball back. So the robot, they had to design something to add on to the robot, like some kind of arms or some kind of scooper to go get baby Yoda, get the ball, and put him in the Millennium Falcon, which is that gray box in the background to the right of R2-D2 in the picture. It was just a shoebox that I glued a picture of the Millennium Falcon on the top. It's amazing how exciting you can make things just by gluing a picture on the top of a shoebox. So they had to code it to get into that. And honestly, we have lots of different kinds of robots in my classroom. My kids love coding with these the best because it's a lot more accurate. The Spheros, you don't know which way that ball is going to roll every time or to what degree. The U-kits are a lot more accurate. And then the third thing, it was Winter Olympics last year. And I thought, well, gee, let's have Robot Olympics. That sounds way more interesting to me than, you know, learning the geography of a country, which I probably should have been doing that too. But on the next slide, you can see the kids came up with,
that one wants to play, so we're going to let it play.
Oh, there you go. Okay. These are all on YouTube as well.
Yeah. All right, there we go.
You can hear me cheering in that one. This one on the left, they made 2 ice skaters, 2 figure skaters that danced together. I don't have a video of that one, unfortunately, but they really did a lot of twirling. And the kids learned so much. And these 2 worked so well together. They're very excitable kids. So I was excited to see them sit that long and work on that. The one on the right was actually curling. One of the kids decided they wanted to do curling. So they used a paintbrush to make the ball curl into the next thing, but they coded that. So that was kind of fun. So it made it, you know, they were learning all kinds of things about angles and degrees and speed and velocity. They didn't even know they were learning it. They just thought they were playing with robots. So kind of cool.
That's fun. All those YouTube links are in the chat. So feel free to pull those and watch the videos on your own.
Awesome. So find something you already do and just make it fun. Yeah. And so then there's curriculum goals you can set. I don't think there's any piece of your curriculum you can't pull out and we can't tell you some way to use it with robots. So pull it out, find a way. If you can't think of something, email me. We'll brainstorm together. We'll find something. But it obviously does critical thinking, which is so big right now, right? These kids need to make decisions for themselves. It obviously does coding. I love to use it for area, perimeter, and measurement. You'll see a picture in a few slides where we redid the Macy's Thanksgiving Day Parade, and I teach it in elementary school. There's a book called Balloons Over Broadway, and teachers spend forever decorating balloons, and the balloons are a really big deal, and then they write a story about it. And I'm like, well, we can make the balloons move. This is way better than decorating. I'm not very artsy. So we just drew on our balloons, tied them to a robot, and then we had to decide the route. And I believe I told them the route has to be X number of miles long. It has to have 3 right turns, a left turn, you know, a 90-degree turn. You can make that as however you like. And then they had to make their robot with the helium-filled balloon attached to the robot drive the parade route. If I had thought of it about 2 weeks sooner, I think I could have made it even cooler, because I would have had the kids build their own float instead of just attach it to the robot. So, and these kits are ideal for letting them create their own. You just do the ATV base, and then they could build whatever they wanted on the top. You know, you could do the float right down the hallway of your school, you know, down the front sidewalk. That would be great for PR. But area perimeter measurement, that is pretty cool. You can just, you know, drive them around the perimeter, and what's the perimeter? Was it in millimeters? Was it in centimeters? Was it in inches? Can you convert it? Creative writing. I did one project where they told a story. We read Call It Courage, and they had to do Mafatu's journey from one island to the other island and back. So the robots had to code, you know, they built a little island, and the robot had to code from one to the other, go through the water. That was kind of fun. You can do something as simple as spelling. Put letters on the floor, and the robot drives to the letters. or drives to the Greek stems or Latin stems or the root words. Then there's, habitats. You can build habitats for the animals. I think Christina even has a whole lesson on habitats, the body systems, geography, where is Ukraine? Let's talk about the war in Ukraine and the war in Russia. Well, let's drive our robot over there. How far is it? Let's measure the distance, right? Can you find the perimeter? All kinds of exciting things you can totally integrate. Anything y'all want to add there? Sorry, that was a lot.
No, I just love all of your ideas. I wish we could if you guys don't follow EC on Twitter, please get on her Twitter. She posts all this stuff. Like, I remember the robots with the balloons, and you just got to watch. She posts, and it's so much fun to see all the things that she does. Yeah, I love it.
Thank you. Step 7, I think, is hugely important. Like I mentioned earlier, you need secondary goals, right? Your primary goal is your curriculum, and that's what everybody's should be, or to learn, your coding. But these kids need teamwork. These kids need critical thinking, communication, the soft skills. I have heard this from high school to college to kindergarten. These kids need soft skills. I coach a chess team. We won the state championship this year, and the kids that are currently in my chess club, have never been allowed to shake hands with the other kid playing a game because of COVID, right? Their last normal year of school was 2nd grade. So that's pretty mind-blowing. My youngest is a senior in high school. His last normal year of school was his freshman year. It's kind of like being transported from freshman to senior, boom, figure it out. They've got to learn how to get along with others. They've also got to learn to persevere. That got poured during the pandemic. Their grit and their perseverance for adults too. We tend to give up. Oh, I'll just turn that off. I'm just going to go do something else now. No, stick with it. Doing robotics is not easy. It's not easy, but that's what makes it so satisfying, because you have to work hard and figure it out. And it's just awesome. And when the kids get it, they get it, and they get it so big, and they're so excited. So encourage that. Now we can shake hands again, look each other in the eye, shake hands. Let's talk nicely to each other. And yes, high school and college kids need that too. I felt like I had to retrain my own kids, and I've got a 21-year-old and a 17-year-old. So not just elementary school. Yeah. Somebody said the kids need scaffolding. Absolutely. They need scaffolding for all the skills that they get. And yeah, teach them little steps at a time, but they figure it out fast. You'd be surprised how quickly they learn this stuff. Number 8, measure your goals. You definitely want to be measurable. It's got to go on your lesson plans, right? You got to check that box and have the assessment and be able to prove to your donors that this made a difference. Pre and post surveys, always good. Rubrics, amazing. I use most of my stuff with rubrics. Now with my class, since they're gifted kids, I have to tell them, failure doesn't mean an F. Your robot didn't get into the Millennium Falcon, or you didn't save Baby Yoda. You don't make an F because you put in the effort, you built the right things. So your rubric shouldn't be based on, the end. It should be based on the journey, if that makes sense. Because the failure on some of these robot things will teach you more than anything else. This picture is the kid, he built a hockey set, and he got frustrated because he was trying to figure out how to code the goalie and how to code the guy hitting, the player, how to hit it in there. And he just got overwhelmed, and he said, you know what? I'm just going to change it up. He came back the next week and he said, okay, now Miss Setzer, I'm just going to have him hit it. He's not going to have a goalie. We're just going to say he got an open shot, right? But the kids learn from their failures, and that's so important. And that's going to teach them that grit and perseverance. Let them assess themselves. Kids are always harder on themselves than you are. How do you think you did? How was your group work? Write it down for me. How did you work together as a team? 1 to 5. What do you rate yourself? Teaching others is huge. If you are a high school engineering teacher or a high school STEM teacher, go find a middle school, go find an elementary school, turn on a Zoom, come teach my class, right? Zoom with us, teach somebody else. When you teach somebody else, you are learning better than if you ever just learned it on your own. I think all teachers know that. Self-reflection is huge at the end of the project. What would you do differently next time, right? All STEM projects should have that at the end. They need to know what they did right, what they would change. I don't necessarily say what you did wrong, just what you would change next time. And we'll talk about that, and they get so many ideas from each other, and it's great conversations. Next time I would change the angle of my servo. I'm like, okay, I don't know what you're talking about right there, Casey, but that's okay. We'll try it next time. And some of them will beg you to take a kit home so they can try it again at home and show their parents, which is exciting.
Right. And that the whole the explanation of what they would do differently just ties back into that engineering design process, right? And that design thinking. It's never, this is the best I can do, I'm totally done, nothing can be improved, right? There's always something that can extend.
Exactly.
Absolutely. Where do I start? Add your class, open your classroom. Step 9, let people know about this, right? Invite them into your classroom. I got so frustrated 2 years ago. I couldn't get anybody to come in my room. I'm like, come in. And that was when parents couldn't come in. But now we have this wonderful thing, thanks to the, thanks to COVID. One thing nice for COVID, we have Zoom, right? Turn on a Zoom, invite your parents, let them see what your kids are doing. Make a video, post it on Twitter. Send it to your PR department at your school district. Teachers don't do that. They don't PR themselves enough. It is so easy to PR yourselves now with Instagram, Facebook, Twitter. Obviously, make sure your kids have media releases that you can be sharing their information. If not, make some kind of private YouTube channel, something private that you can share with their parents. It's kind of like the people that get to watch their babies in daycare now on a monitor. They can log in and watch their kid. How cool would it be to get on your kid's classroom and see what they're doing today? Super cool, right? So make a video, give them a glimpse into your world. Create videos and put them on your school news. Put it on your local news. We have a great guy in our district who does PR, and he'll come. I'll say, oh, Andy, I've got a big project. Come see my Star Wars Day. And he'll just show up with the cameras and send it out on the district's Twitter feed as well. And the kids' excitement, once they see those kids, it is contagious. One of the special ed kids, he had autism and he didn't talk much. He was good at coding. He would come in, he would do everything. And when we had Andy in there taping the kids to put on the news to show blurbs, that kid stood up, he took a microphone and stood up and commentated it like he was Dan Rather. And he told everyone about his project and where that robot was going and how it was turning. And he just came out of nowhere. And Teddy's grandfather emailed me and said, Miss Setzer, where did you get those robots? I want to get it for him for Christmas. So that kid might not be able to read a whole 4th grade book, but that kid might be a coder someday for us. So kind of cool. You never know what's going to excite someone.
That's amazing. I love that. All right, step 10.
Remember, you are not a robot. You will mess up. It is okay. If you are freaking out and panicking and can't find any other way out, email Rusty. He will help you. Email Christina. They will help you. Ask questions. Ask. Google it. I have a good friend who used to work at NASA who's a computer guy. And I used to call him when I get stuck on my computer. Clark, I don't know how to do this. I don't know how to do that. And he said, easy, Google it. There's some nerd out there bigger than you who wants everyone to know he knows how to solve this problem. And that's true. 99% of the time I can find an answer online. And you know what else helps you? Hand it to the kids. I need you to problem solve this for me. Miss Setzer can't figure this out. This is your job. See if you can figure this out. And most of the time the kids can figure out what you can't figure out. Ask for help. Email me. I'll do my best. I might not have taught, high school AP physics, but I could probably help you problem solve your robots. Let me know. And I am not shy to text my own children in the middle of my class or FaceTime my college engineer kid and ask him how to do something. And the kids are used to it. It's okay. They need to see you asking for help. They need to see you don't know it all. That's important.
Mm-hmm.
It's super important to help them problem solve, right? Like, how would you do it? And if they see you doing different various things, that they're like, oh, well, I can also go do that, and all kids are device savvy now. So they'll, if you just show them the resources, they will figure it out.
They will.
For sure. Those people in the chat, we've got some great apps that are being shared and things that you can do in the chat as well. So please make sure you're checking that. We've got some awesome contributors this time. So thank you so much for adding in.
Awesome. And this is my last slide. This be creative and have fun. If you're not having fun with it, you got the wrong robot kit. Send it back and get a UBTECH one. They didn't pay me to say that, I promise. But have fun, make it interesting and exciting. This picture on the left side is that's our special ed friend with one of my gifted friends. And they said, Miss Setzer, we want to 3D print this obstacle course and we want our theme to be under the ocean. And I said, you know what? I've got some robots that are waterproof. Let's get an inflatable pool. So, and then it turned into all kinds of problem solving challenges because all of those colored things in the pool that you see are 3D printed in our classroom. And 3D prints are typically kind of hollow, right? So we had to add weights. A lot of them have pennies taped on the bottom, weights from our balance scale taped on the bottom. So it became quite the challenge. We didn't think about our obstacle course floating away. So that was kind of fun. But we did an obstacle course through there. On the right side is our Macy's Thanksgiving Day Parade, which we made Parade Over Pinckney because that's the name of our school. Those mats on the ground there, those are called Canasium Mats. They're kind of cool. They're like foam rubber, like you use for a yoga mat, and they've got holes in them. And you can put these cards in any configuration you want to make mazes. So those are great for coding too. And like I said earlier, if you've got a UB robot that just can drive right through those things, and the UBTECH robots can go, the UKIT robots can go over ramps, and they're pretty strong. So that's a cool little combination. There's a good grant for you. If you're looking for something to write a grant for, a UKIT and the Canasium Mat together is a good one.
There you go. And Rusty, I'll ask you this question since it kind of ties in with this slide. Are our robots waterproof? You're muted.
I wouldn't try it with that.
I know. I was like, I'll see what Rusty says. Rusty, you got to unmute.
Muted.
Oh, maybe he doesn't hear that he's muted.
You're still muted, Rusty.
There you go. Now he heard us.
Whoops. Yeah, sorry guys. I was just chatting away. No, they are not waterproof. So they're not tested to be, water resistant. However, you could definitely, create some waterproofing, though, we could work with you on that, but in general, no, as is, no.
I probably wouldn't put them in the water. Those are Sphero bolts that are in the water. And I didn't believe they were waterproof, and they told me they were waterproof. So I was all planning to, watch them do something crazy, and then I was going to get a new one, and they didn't. So they're not as accurate. They're fun for something like that. Every robot's got its own quirks about it, but that one, it was fun for that, but it's hard. It's more frustrating to the kids coding wise.
Yeah,
for sure.
But maybe younger kids, it might be a good starting, it's a good gateway robot.
There you go. Yeah. And that's something we get a lot is, how do we differ, or what are the differentiators or whatnot? And really there are a lot of coding robots out there that you're not necessarily engineering, right? You're not building it, you're just programming it. And so we kind of set ourselves apart a little bit that way because we're an engineering kit, right? So you have to build it before you can play with it. So that's one of the things that we talked about. But yeah, so there are you'll see a lot of those, and especially I feel going down to K2, right? We've got a lot of those robots that they can go over tiles, or they can be programmed with buttons, or different various ways to get the younger kids in there. So it's great to get them started with coding, not necessarily for engineering.
Mm-hmm.
Okay,
right. Any kind of robot is a good robot.
Absolutely. We don't say no to robots, for sure.
Yeah.
We are going to skip this slide so that you guys that have questions have a chance. Get your questions in if you have questions specific for EC, questions for us. I know we're a little bit over on time, so I apologize for that. She is just such a wealth of information. We had to get everything out of her that we could. And Rusty and I are a little slow today since it's our first live webinar back. So I think we're back in the swing of things now. Hopefully this is better. We do have some questions I'm going to ask, but you guys type your questions in. We're going to skip to the next slide, give you a heads up. Next webinar is September 17th, same time, same place. We're going to talk about robots and other subjects. So how can you tie in robots? Like EC gave us a ton of ideas today. How can you connect the dots and put robots with different class areas, not necessarily just STEM or just engineering or just computer science? How can we get it into other spots? And then just a reminder, if you don't have this already, you can reach out to us at any time. And EC has told you we are very open. You can reach out to Rusty and I. We will respond to you. You can do social media, you can do email, whatever you want to do. Most of the time, if you email with a question, it goes to us, and we will figure it out. But do reach out to us. Do check out our social media platforms, or where we're at on social media, I should say. Check out our website. Tons of free stuff on there. Pricing's on there, more information's on there, free stuff, there's tons of stuff on there. The webinar is recorded. A link will be sent out tomorrow. You can also find it on that webinars tab. Going back, if I can, that was EC's slide, don't mind that. Different ways you can get a hold of her. I'm not used to running this PowerPoint, can you tell? Okay, Here we are. We are back. Bye, Lori. Thanks for joining us. Lori just said she needs to go. Q&A. So go ahead and hit us. Hit us with your questions. Jonathan's asking how you spell Canasium. So it's K-I, if I said that right, K-I-N-A-Z-I-U-M-E-C. Put it. Oh, EC, you just responded to host and panelist, which I do all the time.
Oh, sorry. Responded
So
to
if you can send it to everyone, everyone will have it. Those people that are jumping off, thanks so much for joining us. We're going to ask EC a couple of questions now, or maybe Rusty, I might throw one his way. Feel free, type in the chat, anything else.
Oh.
You are very welcome, Kate. Thanks so much for coming. Okay, EC, are there any suggestions for starting a robotics program for grades K through 2?
Absolutely. I have done robotics with K through 2. I would start with, basic coding first. Which you can do with beads on a string. There's great lessons out there for coding with beads, coding with cups, coding with blocks, and just teaching them the patterns to things. When I taught 2nd grade, I started with Ozobots. They're a little bit smaller. There are other robots out there that are a little less advanced than these, but I would start with these and build them for them. You can do the build part if that's too much for them. 2nd graders can handle it. Kindergarten and 1st, they might have to be a special kind of kid to do the build part. But if you're worried about the build part, you can build it for them and then they can do the code. They don't have to do everything. Ozobots is more of line code. They draw with markers and then the robot follows the line and it changes based on what colors there are. Like if it's red, blue, red, it might flash 3 times. There are also Sphero robots that I showed you earlier. There's mini Spheros, which are about $50, and then the bigger ones are about $150. Those are good. You just have to make sure the kids don't joystick drive them, because there is an option where they don't have to code. They can just joystick. And I always tell my kids, no joystick driving unless you're just retrieving it to come back to you. So things like that. But yes, you can absolutely do these things with kindergarten, 1st and 2nd graders. Pair them with older kids. If you got a K to 5 school, go find a 5th grader to come work with your kindergartners.
For sure. I've never considered the teacher building the robot, and that's perfect because you could have the way ours are set up is they Bluetooth to the MCB or you can Bluetooth it to the Arduino compatible controller. Not that you would be using that with kindergarten, but if you're going to use just our regular one, you can have all the kids with their devices building their code, and then they could individually connect to it and run to it. And that's a fantastic idea. I never thought about that.
Yeah, it connects to that. That's what's cool about the UKids is they connect to more than one device.
Yeah,
so
and I love what EC said about teaching coding outside of technology. I think there's so many really interesting and fun ways to teach, logic and sequencing without technology. I had a teacher that we worked with that was utilizing coding within a dance setting. So they were doing dance routines, but it was with the idea of, getting the students to think about computational thinking. So there's so many different ways you can do it with younger audiences. I don't think coding by any means is an older student, only type activity. I think it easily can be brought down to K2. And yeah, there's a lot of robots that are also really helpful. I love the Wonder Workshop robots. There's not a ton you can do with them for, more advanced kids, but kids love them. I mean, my daughter loves it. She's driving that around all the time. So
those are good donors choose grant ideas.
Yeah, exactly.
My favorite younger robot are like screenless, right? Screenless coding is Kubo. I love Kubo, and he runs over the little tiles and his little face lights up. I think that's fun. And he makes fun noises. Speaking of what products are best for students, we have a question of what products or robotics. Real quick, I just remembered. We also offer a K2 AI Foundations curriculum, which I know sounds scary saying AI, but it teaches the foundations of computer science with hands-on activities not tied to coding. So going with what Rusty said, if you want to just get them introduced to the idea without actually doing the building and coding, you should check out our curriculum as well. Okay, what products are best for middle school age students? So Rusty, real quick, do you want to talk about what products we have that are good for middle school? And then we'll let EC throw in whatever else she uses with middle school students.
Yeah, absolutely. So our products really do kind of span, they hit the middle school age very well. And all 3 of our kits really hit that kind of sweet spot, in my opinion. Because we engage in, the complexities of building as well as coding. The coding can be scaled specifically to meet the needs of those students. And then we have curriculum that supports our intermediate curriculum as well as our advanced curriculum will support those grade levels, 6 through 8. So to be honest, kind of thinking about which, where your students are at, and then kind of deciding which kid is right for those students, I think but all of our kids will really hit that age range really well.
Mhm. All right, EC, what do you got to add outside of UBTECH? What do you use with middle school students? Oh, you're muted too.
I am
There you
muted. I probably use Spiros with the older kids, or outside of UBTECH. See, I would go to UBTECH with middle school kids because they love the build part. Yeah, I mean, unless you're going to get into Makey and Arduinos and start doing those add-ons, I think that's, you got to go with you kids.
We love
You got to go with you kids.
We love that. Okay, so our last question, because I think we had a question about standards. So we address NGSS, like we said, so it's national standards. If you have local standards that you're looking to address, my suggestion would be to look at the NGSS that we touch on, like the actual description, and see how it correlates with what you have in your state. And if nothing else, you can send it to me. I will take one for the team. Standards are not super exciting, right? You can send it to me and I can help you work through how you would address those standards. Last question, unless anybody else types anything in. We did have a comment about Yanchi. EC has her own Yanchi. EC, would you like to comment on Yanchi?
He's super cool. Sings, dances. Everyone in my family got to hear him sing happy birthday.
Nice.
Yeah, that's a really cool robot.
Yeah, my dad's favorite is to get him to play Gangnam Style. He likes that dance.
Yes.
So much fun. Okay, last question. So a lot of robotics competitions are out there, right? And they utilize all sorts of different robotics. We are not in the robotics setting yet. But why would you choose UBTECH? And maybe we'll start with EC. Rusty, I'm going to skip you real quick. Why would you choose UBTECH over those robotics companies that are really big in the competition space?
I actually got pulled in to be a coach of my son's Mindstorms team several years ago, and with a bunch of kids that knew all that stuff much better than I did. That was probably my first introduction to all of that world. And the kits were not accurate. Like the motors didn't spin the speed they said they were going to spin. They had a ton of issues and they went bad really fast. I haven't found that with these kits. Like I said earlier, these kits are a lot more accurate. So if you're dealing with middle school and high school kids, they're all about that to the 10th of a degree and the one, to the whatever mile an hour speed that they need. And they're going to get a lot more frustrated if they're using a lesser robot, because it won't be as accurate and it won't be as fun for them, because they want it to accomplish what they're trying to accomplish.
Very nice. That's good reasoning. Rusty, anything to add to that?
No, I mean, I think we've had some great discussions here. So no. Yeah.
Perfect. We do have a question. How much for Yanchi? I'm not sure. I don't think any of the companies anymore are selling them in the US. So you would have to look elsewhere for Yanchi. He was very special, and I don't remember what his price point was, but he was not an engineering robot. He was more so put him together once, you're done, and then do a lot of programming with him. So it's a lot of open-ended and specific programming. So yeah, there you go, Arnell. Yep, go ahead and look overseas. You will probably find him, but in the US, I don't believe any of our resellers, anyone is selling him anymore, unfortunately. So we are just really focusing on our UKITs in the education space and trying to promote engineering robotics as opposed to the fun, even though the humanoids are so fun. I love Walker because he's like my size and walks around and stuff, but not really practical for the classroom. So so there's that. I think we are good. I hope we answered everyone's questions. I haven't seen anything new come through for a while, question wise. So if you've got anything else, we can stay on for a couple minutes, but otherwise this was fantastic. Thank you all so much for joining us today. We hope you learned how to get started with robotics. If you have any questions, reach out to us. If you want to reach out to EC, that's totally fine too. That's what our TAP teachers are for. They are ambassadors and can help you with the real life classroom situation. So thank you again. We hope you guys have a great school year. We will see you next month.
Yeah, thanks,
thanks.
everyone.
Hi, everyone.
Easy. Appreciate it. Talk soon.
I'm sorry, what'd you say?
I said thank you.
Oh, you're welcome. That was fun. Sorry, I